In this week's practical, we were assigned the task of taking a standard physics experiment and measuring the non-ideal physics. After brainstorming a number of ideas including pendulums and springs, we decided to examine the non-ideal physics of a weight sliding down a ramp. In the ideal experiment, the ramp would be frictionless, meaning that after the mass reaches flat ground, it would continue at a constant velocity. However, as there is non-ideal forces acting upon the weight, this wouldn't be the case. We chose to conduct this experiment as we knew our camera could record at 120 frames per second, meaning that we could calculate the instantaneous velocity of the object when it hits the flat portion of ground. This ultimately would allow us to be able to measure and calculate the non-ideal force present in the system, which caused the non-ideal results. We began the experiment by setting up a ramp made of Hot Wheels tracks. The start of the ramp was set at 50 centimeters above the ground. We marked the point at which the gravitational potential energy had all been converted to kinetic energy, i.e. at the base of the ramp. We then placed a 50-gram metal weight at the top of the ramp and allowed it to slide down until stationary. We filmed the flat portion of the ramp with a ruler next to it. This footage was used to calculate the instantaneous velocity of the weight at the base of the ramp as well as the distance it took the weight to lose all kinetic energy and stop. This process was repeated multiple times in order to increase the accuracy of the experiment. Using frame-by-frame analysis, we determined the average velocity at the base point was 0.84 meters per second, and on average the weight slid 29 centimeters before stopping. By determining the change in energy between these 2 points, we would calculate the work done by the non-ideal force. Through assuming that all non-ideal force was due to friction, the friction coefficient could be determined through the shown calculations. As shown, the coefficient was determined to be 0.124. Through further research, we found that the kinetic coefficient of friction between a metal object and a plastic object ranged between 0.1 and 0.3. In conclusion, it was determined that the non-ideal force present in our standard physics experiment was the kinetic force of friction, which had a coefficient of 0.124.